Welcome to Context Aware. In a groundbreaking achievement, the NASA's Psyche mission has just marked a historic milestone in space communication. Launched in mid-October, Psyche is en route to explore a metal asteroid between Mars and Jupiter, covering an impressive 2.2 billion miles. What makes this mission truly special is the inclusion of the Deep Space Optical Communications Technology Demonstration, DSOC, which has just achieved first light. DSOC, NASA's most distant experiment in high-bandwidth laser communications, recently demonstrated its capability by successfully sending and receiving data from nearly 10 million miles away. The laser used in the experiment can transmit data at speeds 10 to 100 times faster than traditional radio wave systems, potentially shaping the future of communication with Mars-bound human missions. As Trudy Cortez, Director of Technology Demonstrations at NASA, stated, achieving first light is one of many critical DSOC milestones, paving the way toward higher data rate communications. Part 2. Sending lasers across space, a technological triumph. On November 14, the DSOC experiment achieved a significant breakthrough as the Flight Laser Transceiver instrument on Psyche received a laser beacon sent from NASA's Jet Propulsion Laboratory's Table Mountain facility. This test, referred to as First Light, marked the first full incorporation of ground assets and the flight transceiver, showcasing the collaboration between DSOC and Psyche operations teams. Meera Srinivasan, operations lead for DSOC, emphasized the challenges faced during this experiment, stating, "It was a formidable challenge, and we have a lot more work to do, but for a short time, we were able to transmit, receive, and decode some data." This isn't the first time laser communications have been tested in space, but DSOC stands out as the first to achieve laser communications across deep space. This achievement necessitates precision and accuracy over millions of miles. As the team continues refining the laser's pointing accuracy, DSOC is gearing up to send and receive data to the Hale telescope as Psyche ventures farther into space. Part 3. Future challenges pushing the boundaries of communication. While DSOC won't directly send scientific data from Psyche, it plays a pivotal role in the future of deep space communication. The laser will transmit test data encoded in photons or quantum light particles, paving the way for a new era of optical communication. Dr. Jason Mitchell, Director of NASA's Space Communications and Navigation Program, highlights the significance optical communication is a boon for scientists and researchers, enabling human exploration of deep space. More data means more discoveries. As Psyche faces more challenges on its journey, DSOC will monitor the time it takes for laser messages to travel across space. The initial success of DSOC suggests a promising future for high-speed, efficient communication in deep space, revolutionizing the way ENASA sends and receives data from its missions. Part 4. SpaceX Starlink Space Lasers Revolutionizing Satellite Communication. Shifting gears from deep space to Earth's orbits, SpaceX has achieved a major milestone in satellite communication with the successful test of Starlink satellite space lasers. These optical communication tools, resembling lasers, could redefine the landscape of data transfer in space. Of the 715 Starlink satellites launched, 2 have tested prototype lasers in orbit, marking a significant step towards an upgraded version 2 constellation. The introduction of laser interlinks in Starlink satellites offers several advantages, with a significant reduction in connection latency being one of the key benefits. Laser interlinks enable a more direct route for data, minimizing the distance data has to travel and enhancing overall network performance. As SpaceX advances towards a fully interlinked Starlink version 2 constellation, the potential for lower latency and higher bandwidth connections becomes a reality. Part 5. The future of satellite communication, Starlink's next phase. With the successful test of Starlink satellite space lasers, SpaceX is on the brink of a new era in satellite communication. Laser interlinks promise not only lower latency, but also the ability to service a larger geographic area, bypassing some of the challenges associated with ground station installation. As SpaceX eyes latency as low as 8 milliseconds and aims to raise individual connection bandwidth to a gigabit or more, the future of satellite communication looks promising. SpaceX's journey from version 1 to version 2 of the Starlink constellation represents a significant leap forward. As the company finalizes a viable Starlink version 2 satellite design, it paves the way for enhanced performance, marking the next phase in the evolution of satellite communication. Stay tuned to Context Aware for more updates on these groundbreaking developments in space technology.